All right, this is chapter 3-6, parallel lines in the coordinate plane, along with chapter 3-7, perpendicular lines in the coordinate plane. Please copy your cuts, and we're going to begin. We have to go back to algebra and pre-algebra. We're using slope-intercept form for graphs. We should remember that y equals mx plus b, where y is going to be part of your ordered pair, and your m is your slope. Your x is part of your ordered pair, and then your b is your y-intercept. Your y-intercept is the point on your graph where your actual line will cross over the y-axis. Okay? So here is our slope-intercept form. We should remember y equals mx plus b. For example, have two equations. Example 1, y equals 3/4 x minus 2, and then I also have y equals 3/4 x plus 1. Both of these lines are parallel because m, or the slope, in other words, are congruent. The rise over the run is 3/4, rise 3, run 4. Okay? Therefore, meaning these two lines, whenever my slopes are the same, it doesn't matter that my b's will be different. As long as my slope, my m's are the same, I will have parallel lines that will never, ever touch. My y-intercept on the red line is at -2. Remember, the b, or in other words, the y-intercept means the place where you cross the y-axis. So if I wanted to start to graph this, if I were doing this initially, I'd start at -2, and it says rise up 1, 2, 3, and then run 1, 2, 3, 4. Okay, and if it were a little more skewed up, it would match up nice and beautifully. Same thing with my green line. My y-intercept would start at +1, where it crosses the y-axis. Remember, your y-intercept is where you're going to cross from the left side over to the right side of your graph. Rise up 1, 2, 3, run 1, 2, 3, 4, and this will be my first point. Rise over run. And again, parallel lines, the slopes will be exactly the same. Slightly different for perpendicular lines. Okay? Perpendicular lines, if we remember, are 90 degrees. They're exactly going to form 4 right angles. So the red and the blue line form a perpendicular line, or lines. So I will have 4 90-degree angles. How do I determine when my lines will be perpendicular? M, or the slopes for these two, will be negative reciprocals. So on the first one, and I know it's the red one because the slope is 5, 6, which is positive, and my red line goes in the positive direction, so this will correspond to that. My slope is 5, 6, and the blue line, because it's perpendicular, its slope must be the negative reciprocal. So the reciprocal of 5, 6 will be 6/5, and because it's positive, it will become negative. Therefore, letting me know that this is going to be a perpendicular line. Okay? Example 2, if I had two lines, and the y equals mx plus b, if I'm just only looking at the slope or the m, if my slope for the first one is at -3, which really means -3/1, if I were looking for a line that's going to be perpendicular, that automatically means that my slope must be the reciprocal of -3/1, which would be a positive 1/3. Positive 1/3. Right? Let's determine a couple of things here. Looking at this particular example, given the following information, let's suppose I have 3 lines. And I'm trying to determine if any of the lines are parallel or perpendicular. Well, if I'm given these 2 points, and I know these 2 points lie on the first line, -4 and 5, -8, 3 for the first line. And on the second line, I know that it's 2, -4, and 8, -1. Those lie also on some other line. So these 2 lines, this is on one line, and these points both lie on the same line. They're just in different locations. And this is line 2. And these are 2 points on the same line. They're just in different locations. And this is the third line with the points 2, 5, and 4, 1. And the question is, are these 3 lines parallel, perpendicular, or neither? And we can determine that by calculating the slope. Okay? It's best to write the equation in slope-intercept form. But first we need to find the slope. hopefully we remember how to find the slope, or m, equals delta y over delta x, back from pre-algebra. That's y2 minus y1 divided by x2 minus x1. So y sub 2 minus y sub 1 divided by x sub 2 over x sub 1. Now let's suppose I want to compare the first line and the second line. I want to find the slope of the first line, excuse me. So if I'm going to use this first line here and find the slope of this particular line, these 2 points are on that one line. If I want the slope of it, what do I do here? So y sub 2 is 3 minus 5. So this must be, these are my 2's, these are my 1's. This is going to be x1, y1, x2, y2. Okay? So I have 3 for x2 minus 5, which is your x1, divided by x sub 2, which has to be this negative 8, minus the negative 4, equals negative 2 over negative 4, which is a positive 1/2. So this is the slope of my first line, which I'll just let that be the red line. The question is it parallel to the second line, which is this 2, negative 4, 8, negative 1? Let's see. I have to find the slope of that second line. Again, the slope equation is delta y over delta x, being broken down as y sub 2 minus y sub 1 divided by x sub 2 over x1. And same thing like before. If this is going to be my line 2, I'll make this the green one. You need one of them to be your 2's and one to be your 1's. So in this particular case, these are going to be my 1's again. This will be x1, y1, x2, y2. And substituting in here, x sub 2 will be negative 1 minus x sub 1, which is my minus a negative 4, divided by my x sub 2, which is going to be 8 minus a negative 4, which equals, in this particular case, I have negative 2 over 4, so I must have wanted this to be a 2. Up there, I wrote the wrong, looks like I wrote the wrong value in, but negative 2 over 4 will be a negative 1. I did something all boo-boo around here. Anyhow, I wanted this to equal out of a slope of 1/2, and if it did equal that, which it doesn't, because I did some configuration that's not correct, if this slope were also equal to a 1/2, you would know that the first and second line would be parallel to one another. And if you look at the third line, which I'll make blue, the 2, 5, and 4, 1 on there, if I take and make this my blue here, same thing, x sub 2, delta y over delta x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, be 5 minus 1 divided by 2 minus 4, and be 4 over negative 2, and this will be a negative 2. And the question is, what is it in relationship to these two? This is the negative reciprocal because it's a negative 2 over 1. That's how I get a negative 2 for m. That means that this is going to be perpendicular to the first and second line. And the first and second line, if this were really 1/2, these two lines are parallel to one another. And the third line is perpendicular to the first and second line. So here we have this information, if that was correctly written. So what should we notice? The first and second lines will be parallel, but the third line is the negative or the opposite reciprocal. Therefore, the third line will be perpendicular to the first and second line. Okay? What you need to do is make sure you read in your book examples 5 and 6 on page 167, because that is not covered on there. And then also read examples 5 and 6 on page 174.